Have you ever tried migrating code in your project? If yes, you probably know that that's quite a difficult task, and 90% of the use cases finish with nothing. They don't migrate, especially at companies. Companies like to spend a lot of money on engineers, and a lot of engineers work on this migration, maybe try to switch from one language to another one, or maybe from one framework, such as AngularJS to Angular. And most of the times, those migrations don't really finish, or at least finish partially, and then you have some kind of a mutant at the end that you need to support at the same time. But what always amazes me is something like this use case where Figma actually managed to do that, and especially in a very efficient way. That's why I wanted to review this article that they wrote a couple of days ago and maybe share some insights with you guys as well. So I think it's going to be pretty effective or efficient for both of us. So let's get started. Figma had this language called Skew in their house. So they literally developed this language, or I would rather call it a transpiler. It transpiles Skew, which is very similar to JavaScript, or I would rather say TypeScript, but it has some extra functionalities. So it basically transpiles Skew into JavaScript, first of all, which is running in browser. And they wanted to make a language, which is Skew, so that it transpiles into a web code, so for the web platform and for the mobile devices as well. So imagine React Native. It's just that React Native is not for Android or iOS devices, but it's a language that at the same time works for the web and the mobile devices as well. Now, I'm not sure which devices they were supporting back then when they were using Skew. Spoiler alert, they're no longer using it. So let's start. Skew, as I told you, was started at Figma as a side project, and they realized that it's not scaling that well because it was really hard to hire developers who can maintain the Skew code. And it was just a big project because you had to make sure that you write very specific code so that it works on the web and works for the mobile devices. So Figma decided that actually, why not switch to TypeScript, which is the industry standard? First of all, they're going to streamline the integration for both internal and external code via static imports and so on, and has a huge community, more than JavaScript, and seamless onboarding for new developers and lower friction for other teams. So the Skew code would actually look like this. So imagine a class called Node. It has already the int string, that's similar to TypeScript, but def keyword like in Python, I think. So JavaScript doesn't have that. And it would basically compile to something like this in TypeScript. Now, the actual migration that they did became possible only in the very recent years with the help of the WebAssembly. So the thing is, Skew had some parts that was compiling into C++, or rather C#. And they needed this for optimizations. It was C++. For optimizations in the browser, because it's like a canvas based, it has WebGL and so on. They needed to be very fast, so they couldn't simply use TypeScript with C++ because TypeScript is a different language than C++. But now with the help of the WebAssembly, they can actually do it much easily. So they replaced many core components that I told you about that rely on the canvas and have to be efficient from the Skew engine with the corresponding components from the C++ engine, which meant we wouldn't lose as much performance if we moved to TypeScript. Exactly. And the team growth allowed to allocate more resources on TypeScript to focus exactly on that. Now, as you know, when TypeScript gained like a very good support recently, I would say the last 4 or 5 years, or even 4 to be precise. So they're saying when we first built Figma's mobile code base, mobile browsers didn't support WebAssembly. And this is true. Like back in 2016, when Figma was starting to get more and more traction, there was still no WebAssembly, at least widespread. This meant that it wasn't possible to use our main C++ engine code or to compile to WebAssembly. At the same time, TypeScript was at its infancy. Wasn't the obvious choice for compared to Skew, which had static types, exactly as we saw in this screenshot here. They already had static types, but still obtained widespread mobile support by 2018, and according to the test, reliable mobile performance by 2020. So after doing some tests, they actually realized that moving to TypeScript actually wouldn't be so bad performance-wise. Now, the actual conversion to TypeScript, this is the most important part and the most interesting part in my opinion. So on one of their internal hackathons or like hack weeks called Maker Week, where they apparently try new things, they tried having a pipeline that would compile to TypeScript at the same time. And they tried this and it kind of worked. So they decided, you know what, we're going to go for it. And at the same time, we're going to write Skew. So there's still the old language that lives within the company, and they're going to build Skew. They're not going to build TypeScript. So looking at this graph that we have here, so the engineering development goes like this. They write Skew code. The Skew compiler bundles into JavaScript code and also the mobile code and takes the C++. And actually, I did a bit of a research. So the Skew looks like this. You have some more information. It actually can compile not only to JavaScript, but also many other languages. And I read some old GitHub issues from even Evan Wallace's. I think this is the guy who invented ESBuild, also within Figma. He wrote some comments about it and also found some interns comment on saying that the tech stack of Figma actually used to use the thing called asm.js. This is like a predecessor of WebAssembly, and it's at the moment is deprecated and nobody uses it. So this is another proof that Figma could already easily switch to WebAssembly. Now going back to the screenshot, the JavaScript bundle from here was going to production from Skew. But at the same time, they decided to write another transpiler that would transpile Skew code into TypeScript. So now they're not only maintaining Skew to transpile Skew into JavaScript and maybe Objective-C, but they're also transpiling Skew into TypeScript. That's too many languages, but wait for it. It's really worth it. So TypeScript then was using ESBuild to be transpiled, a transpiled bundle at the end of the day. Now the phase 2, also interesting. Let's look at the screenshot. We're still writing Skew code and it gets transpiled into JavaScript bundle that goes to the production, but the transpilation to TypeScript and the further build also goes into the production. So they had kind of a gated rollout where they could do green-blue deployment, meaning they could route some of the traffic to the TypeScript bundle to just analyze whether it's working or not. And well, I already read the article and they were saying that they still had a lot of type issues or type errors. The thing is, they decided that during compilation, TypeScript is going to complain that you haven't defined types, there are some typing errors, but they turned them off. They turned them off because they needed to kind of keep this momentum and accelerate and not worry about rewriting the whole code base, but rather rewriting some parts of it, one by one, and still tolerating some of the errors. Of course, not the critical ones that would crash the application, but the type errors were fine. And in the last phase, they completely ditched the Skew code. There's no more way to the production, and they focused on optimizing the TypeScript files in Git or in their code base and fixing those issues as well. Now, they faced a couple of issues along the way, and let's talk about them. So first of all, they had some performance issues with array destructuring. Apparently, it's a very slow thing also within JavaScript. So whenever the Skew code, like here in this screenshot, was being transpiled to TypeScript, it was ending up in a very slow piece of code. We're going to talk about why. And then Skew's devirtualization optimization. So what is devirtualization? Devirtualization is a process, I think in C++, where the compiler, not a compiler, I'm not sure if it's I think it's a compiler, yeah. It's a compiler optimization that actually takes out some of the functions of the class to literally optimize it. Correct me if I'm wrong in the comments below. And the last one is that the initialization order matters in TypeScript, but it didn't matter in Skew. So let's take a look at the array destructuring first. So this piece of code, const AB, and then you're literally destructuring it from some kind of a function that returns an array, all right? So JavaScript constructs an iterator that iterates through the array instead of directly indexing it from the array. So if you write a TypeScript code like this, or like a JavaScript code like this, under the hood, the C++ code is going to be indexing the whole array apparently. So instead, the solution was that we generated code to directly index the arguments array instead of destructuring. So they kind of didn't do destructuring anymore, and they improved the performance by 25%. Next, the devisualization. Another issue was divergent behavior between how TypeScript and Skew deal with class methods. So basically, my object, my func, was becoming my func, and this was leading to the object being null and weird or compilation errors. So to recite them, we added logging in all functions. After enabling this logging for a brief period of time, we analyzed our logs and fixed all the performance problematic call side, making us more confident in the robustness. All right. And the last one, initialization order matters in TypeScript. So whenever we import the code in TypeScript from one module to another, the order really matters, because you're importing this at some point and the compiler sees this piece of code when you import it. But apparently in Skew, it wasn't like that. Skew was processing all the symbols within the file all at the same time. All right. Now, another cool thing that they did is keeping their developers happy, meaning that during this phase when they were transpiling Skew into TypeScript, they still made sure that they generate source maps. Of course, this kind of required extra engineering time and effort, but as long as they did it, their engineers were more happy debugging the bugs there. All right. Another thing that we also need to talk about is the conditional compilation. Conditional compilation meant that some parts of the code had to still be in Skew, but some parts of it had to be compiled into TypeScript, and TypeScript didn't want certain parts of Skew specific code. So something like this, let's say. So if build equals test, then generate this kind of a class, which is basically a TypeScript class. Otherwise, generate this Skew code. All right. So this wasn't working well because TypeScript wants the whole code and it doesn't respect these variables during the build time. So what that is that instead we had to perform the conditional operation in the build step after type checking. So they made sure that type checking was fine, but then made sure that ESBuilds defines a dead code elimination feature. So it basically treated the other part as a dead code and was eliminating it during the build time. That was pretty much it. If you're interested and curious about learning more, go check out their article. I'm gonna link it in the description below. And I will see you guys in the next video. Have a great time.